So I was asked to help out on question 3 of section 12.2. And in general, the way I suggest you get help is start with the question help, view an example, and they will have a very similar question. So like in this case, they have an ANOVA table like they do for your problem, and it'll take you through how to use, how to build the answers from what you're given. But let's go through this again with my help and see how much trouble we get into. All right, so the accompanying ANOVA table and information are the results of randomized block ANOVA tests. Complete parts A through E. So if you look at this, you have rows, and then what Excel calls rows, the book calls blocks. So when it asks how many blocks were used in the study, B minus 1, the number of blocks minus 1 is 7, and so there must be 8 blocks to have a degrees of freedom of 7. Okay. How many populations are in this test? Well, population is represented by K. Degrees of freedom is K minus 1. We're looking at columns for our populations. So K minus 1 is 3, so that means there are 4 populations in my case. Determine whether blocking is effective using an alpha equal to 0.05. Determine a null hypothesis. The null and alternative hypotheses for this test. Choose the correct answer below. All right, so we're looking for the mean of the blocks to be equal, and there's 8 blocks. That's what we learned up here. So mu of B1 equals mu of B2 all the way to equals mu of B8 is the null we want, but blocking is effective belongs in the alternative. So some of the means can be equal. That's not a problem. So over here on F, in my example, all means are unequal. No, it just not all of the means need to be equal. Some of them are equal. That's fine. All right. F test statistic for blocking. We're going to come across rows to the number 48.24. That would be, in my case, the F test statistic. P-value, again in the rows, p-value is 0. And we only have to put in 1 0 for Pearson. And the p-value of 0 is definitely less than 0.05. P-value less than alpha is reject. There is sufficient evidence to conclude that blocking was effective. Test the main hypothesis using alpha equals 0.05. All right, determine the null and alternative hypotheses. All right, so we have 4 populations. So we're looking for mu of P1 equals mu of P2 equals mu of P3 equals mu of P4. And the only place that's in the alternative in all of these is my choice A. So there we go with that. F test statistic, we're going to go across columns and see 12.29. For the F test statistic, p-value, again, going across columns. So we see 0.0001. And there we go. This is less, 0.0001 is less than alpha, so we reject. Sufficient evidence that all 4 populations do not have the same mean. If you get a reject, that means the means are different, which means you need to run the Fisher's least square difference test, which is where we need this, among other things. So let me. So here on Blackboard, under current contents, files associated with test 2, lecture demonstration, I'm going to grab this lecture demo 12.2. I've already grabbed it. I have it here. So I'm actually going to copy this to a new book because I don't want to ruin the original. And I'm going to start getting rid of a few things here. Don't really care much except about the output here on the Fisher's least square part. Here near the bottom. Sorry, here near the bottom. So let's start filling it in. Alright, so we know that K is 4 from up here at the top. We know B is 8 also from there at the top. Mean square within. So we look at the ANOVA table, what they call error here. That's within, so come across here, we got 263.9. So right here, 263.9. Alright, so I've entered all of those. Now I want to look for this information. There's 4 samples with 4 means over here on the list. We only have 3 going on here. So I'm going to grab this and move this down so that right here I can insert 1 versus 4, and then after that 2 versus 4, and after that 3 versus 4. Alright. So mean 1 is in those 3 squares, and sample 1 has a mean of 191.125. Mean 2, it's these 2 on the left and this 1 on the right. Mean 2 is 181.125. 3 is this cell on the left, this cell on the right, and this cell on the right. And 3 was 225.125. And then 4 is this one on the right and these 2 on the right, and it's 213.375. Alright. Now I'm going to grab these 3 cells going across, pull this down. And take a look at the question. If warranted, conduct LDS, determine which population means are different, select all that apply. Alright, so I have these as yeses, 1 versus 3, which is out of different from my sequence here. 1 versus 4, 2 versus 3, and 2 versus 4, and check answer, and there you have it.